Hello, I am Sena Ohene and this is the Dream Big series. This is a platform for Ghanaian children to visit key personalities and ask them questions about who they are and what they do. This episode of the Dream Big series is all on science. The person who is going to help us understand all what science is about is Prof. Isabella Quakyi, former Dean of College of Health Sciences, School of Public Health, University of Ghana. Prof. Isabella Quakyi is currently a professor in immunology and parasitology. Her office is in this building. Please come with me to meet Prof. Isabella Quakyi. Professor, I am Sena Ohene. Thank you for agreeing to talk to me and all the children watching this edition of the Dream Big series.
Hello, Sena. This is wonderful of you to come and talk to me about my work for the children's series.
First of all, Prof, who are your parents and where were you born? Do you have any siblings?
My father was Isaac Benjamin Quakyi, of blessed memory, and my mother, Grace Quakyi, also of blessed memory. Thankfully, my dad lived 81 years before he died, and my mom 92, so I did enjoy them before they died. My siblings, there's 7 of us, but five living, and 2 girls, 2 of us girls, and 3 boys.
What drives you?
What drives me mostly is my faith in God, and I think that sustained me through all my life.
Prof. Quakyi, how was it like for you growing up?
Growing up was very tough for me as a girl child because girls were supposed to stay at home and in the kitchen with mom, and I wanted to be out with the boys because, you know, my father's job took him on treks and he would often go with the boys, and I wanted to be part of that trekking business. So I challenged, I was always someone's sister, someone's, niece, but I needed to know who I was, I needed to be myself. I wanted to know who was I, why was I on this earth, and what am I doing, what's my contribution. So I was always questioning, why, when I was growing up. So it went on until I really went to Achimota. And then I think I found the reason, for why I think I was born, to make a difference to people's lives from that education.
You are 2 things. Please tell us a bit of these 2 areas of your work.
I am an immunologist and a parasitologist. Immunology meaning that I learn how we as humans take care of ourselves and not die from all the infections around us. So I study how your system, the systems in your body keep you alive. And these are the structures in your body that keeps you alive. And God is in infinite, kindness, is really taking care of everything. All the cells that take care of your body from your blood is made up of marrow from your bone. All the marrow in your bones make all the cells. Your blood cells, your white cells. So that is the immune system. So when you get an infection, all these cells come up. They all specialize in their all different ways. And again, to show you, that's the circulation of, and they align the blood cells. So whenever you get an infection, the infection goes through these nodes, and they immediately engulfed and chewed up and destroyed. So that's how powerful your immune system is. So that's immunology. And then we go to, so these are all the cells which really take care of your body. The macrophages, the blood cells, the white cells, these are all cells of your immune system. And now we then go to parasitology. Now parasitology is all the bad guys who give us grief. And they're made up of viruses, bacteria, protozoan, and the example of bacteria is what I'm showing here. So for example, if you get infection in your lungs, these organisms come in different shapes. This is a rod, spiral shape. This is a bacilli shape, and they really cause, pus, and they cause infections in your lung, infections in your brain, and they're really, really deadly. So these are all the parasites. But then what is good about immunology is that we learn to understand all the parasites and then make a vaccine. Okay, so my job is, one, as an immunologist, understanding the immune system of the body, and then understanding all the parasites that causes grief, and then try and find out the parts of the parasite that I can use as a vaccine. And so a vaccine is really taking the parasite and making it not too infectious. And then when you get an infection, your immune system makes an immunity, and you become naturally immune. So my science of immunity and parasitology combines so that I can make a vaccine, against all sorts of organisms. Currently, we have vaccines against measles, polio, and all these childhood diseases, but we still have a challenge to get a vaccine for malaria. And this is currently the vaccine I'm working on.
How does your work benefit mankind?
Oh, severally. One of them is what we've just discussed, the making vaccines that help children, because when you vaccinate a child, you prevent it from getting the infection. When you vaccinate the child builds up an immune system so that when they go into the environment and they get the infection, they're already immune, so they don't get the infection. Another benefit of my work is really building capacity, teaching, and I love teaching. And one of the benefits of my work in teaching and research is being able to take that the rewards of that into the community. And one of the research that we did was helping Ghana Health Service. You know that the drug of choice for treating malaria is called chloroquine. Because we have overused chloroquine, the parasites have become resistant to chloroquine. It means that if you take chloroquine, it doesn't work any longer. So the new drug of choice is called ACTs. I'll call it short, artemisinin combination therapy, ACTs. But the thing is to go to the community to teach them how to take the drug properly. Because people, the ACTs are double, two different drugs. So when you give it to mothers, they give one half to one child and another one to one child. But you want to tackle, the parasite is so smart that you want to give the two treatments at the same time so that it kills the parasite in different sites. So what happens is that we got a program which allowed us to go to the field to find out how we went to the drugstores, chemical, the first place when people are sick in the village is the chemical stores. So this is our village in Pong-on-Sea. So this is a typical store in Pong-on-Sea where our field site is. And we went with our partners. We identified about 40 chemical sites, and then we designed a way that a poster that we can take to the chemical shops to teach them. The mothers didn't know how to give these drugs to babies. It's all okay giving tablets to children like you will understand. But for babies, we had to teach them that were dispersible, how the drugs are developed and how you can give it through, dissolve it in the spoon. And we actually had, one of us had a baby. We had to take the baby along, to show them how we, gave the suspension to the. So these are the types of things we develop in the research we develop in the lab, and then take it, implement it in the villages. So our work is we teach scholarship, we do research, and then our findings are implemented in the village, and then they also become policy. We bring our visitors from Johns Hopkins and take them to the community where we're working. To tell them about what is happening on HIV and malaria. So there's benefit for both sides. We work with the Ghana Health Service a lot, but these are Johns Hopkins partners who helped us develop this place. We're still working on malaria vaccine. And the mosquito is the one that causes a lot of grief. This is a mosquito that has fed very nicely on someone's blood. in my study of parasitology, we have to study the mosquito itself. I had a friend who was studying the nervous system of the mosquito. We need to understand their mouth parts. This is the mouth part. It's called the proboscis. This is what it literally sticks into your skin and sucks the blood, you know. And when it sucks the blood, it's really full. And it's so smart. If it doesn't inject a chemical into the blood, it will clot. And it wants precious parasites from your blood. So it will put in something called almost like a heparin, anticoagulant, so that your blood won't clot, and it will fill itself nicely and then take over the parasite. And then the parasites that it will inject, this is what happens when the mosquito bites you. It puts in parasites like this, and these parasites go on and infect your red cells. You've heard of cerebral malaria. You know, when a child gets malaria, it goes into the brain. Mm-hmm. This is what the parasite does. You know, it goes into the brain and it attaches to the vessels in the brain. So this is how much, you know, how terrible the parasite is. So you can see why we're anxious to get a vaccine.
You were once the dean of the School of Public Health. What was your role as the dean?
As a dean, your remit is to really uplift the structures, build capacity for the faculty capacity, infrastructure capacity, research capacity, and fundraising, and generally create an ambience for learning.
Why did you choose to be a scientist?
When you look at the cell and you marvel at God's work, even at the cellular level, so I wanted to learn more, you know, and you know, so the whole looking at the microscope and looking at the malaria parasite and looking at bacteria, you know, I literally, you know, for me, it was, you know, the life was opened, you know, to do work in science, but I still didn't know quite which field, you know, to go in, until that I lost an older sister. I was in university first year. I traveled and came back, and my sister had died from tetanus. And I realized that when she was sick, the doctors didn't know what to do with her. You know, they didn't know there was a serum or even a vaccine to tetanus. And by the time they figured out it was tetanus, she was 27, she was dead. So that sent me on where I am now, immunology. So my sister's death directed me to the path of my current profession as an immunologist.
Could you tell us about being part of the WHO team which was developing the malaria vaccine?
In 1983, the stage was set, we thought. Scientists thought we now understand the malaria parasite perfectly. We've acquired the scientific instruments to be able to clone genes in mouse models of the parasite. So the stage was set to clone the gene in the human parasite. So a number of us were assembled from different parts of the world to the National Institutes of Health. And we weren't the only group in the US, National Institute of Health. There were another group in Australia called Walter and Eliza Hall. There was another group working in the MRC in Britain, another group working in Nijmegen, another group working in Pasteur Institute. So it was a worldwide race to try and get a vaccine for malaria. So our group in the US were able to clone, and you remember I showed you the mosquito that has bitten you, and when it bites you, the organism that it releases, you see, if you look at the photograph up there, as it bites you, you see the organisms that it's releasing, we call that the sporozoites. And we felt that if we can get a vaccine to block the entry of that organism into the liver, then we're done. We've got the vaccine. And so we worked very hard, and we thought we had a vaccine. But then when we immunized people, it didn't work. Then we realized that the work had only just started. It meant that we didn't understand the parasite. We didn't understand how the parasite interacted with the human, so it really opened up. All the various WHO centers working on malaria vaccine realized that we have a job in hand. So this is where we are. We're still trying to understand this parasite called malaria, and so that one day we hope to get a vaccine. But as of now, we still have experimental vaccines, but we don't have a vaccine yet.
How is a typical day or week like for you as a scientist?
My typical day is teaching, then interacting with my students, and then a series of meetings, either faculty meetings or university-wide meetings, or you have outreach meetings. When we have field research, then we have to take the whole research team to the field. So this is my typical day. And it can run from 8:30, 9:30 till about 9 o'clock.
Please describe in one brief sentence how you imagine a better world for children.
A better world for children is where our environment is safe, is free from all the infections, from the good drinking water, the sanitation is taken care of, the schools, that a child can grow up in a happy environment, and have free educate themselves to the highest level. An environment that a child can grow up safe and happy.
Prof, how important is a laboratory to a scientist?
The laboratory is a scientist's second skin. A good scientist will always have a laboratory next door, so that when they dream up any ideas, they can go and test it.
What is your favorite story?
I have several favorite stories, but I think the one I enjoyed most is Changes by Amatedu, and of course the biography of a very celebrated scientist who we remembered today. That's this lady Iramadi. He is an eye-opener of a woman who is a brilliant scientist, a woman of faith, a homemaker, one of the best scientists Ghana has. And I think in life we need such role models and mentors. And her specialty was in herbal medicine, and she really set the pace. And so whatever we do, we have to make sure that we leave a legacy. And this great lady is, for me, reading her, it's almost as if she wrote her autobiography, and she died a few months later. It's almost as if she wanted the world to know about her before her death. And it tells her life, and reading through it, how all the challenges that she was just an ordinary person like all of us, and the challenges she went through life to make it, and that anyone else working very hard can also make it. So those are two of my favorite Amatedu's Changes and Rewards by Marian Iramadi.
Thank you, Prof. Isabella Quakyi, for answering all my questions and telling me a story on changes and rewards. We, the children of Ghana, wish you well. We hope your findings benefit mankind.
Thank you very much, Senna. It's been a pleasure talking to you. Best.
I am sure you enjoyed the conversation with Prof. Isabella Quakyi, a professor in immunology and parasitology. Till next time, same time next week on the Dream Big series. Stay well and stay safe. Bye.